then you're going to have x squared. Welcome in this video, and here we are going to explore a very interesting concept known as implicit differentiation. You could be asking yourself, what do we mean when we talk about implicit differentiation? Well, it turns out that some functions, if you try to write them in terms of y, it is very difficult. Such functions, we can use implicit differentiation to find their first derivatives. So if you look at our function here, x squared plus y squared equals to 5. If you try to write that function in terms of y, of course it can be possible. If you try that here, if you have y squared is equals to 5 minus x squared, then the value of y is going to be 5 minus x squared power negative half or power half. So very clearly, if you look at this function, think you can be able to solve this function or to find its derivative using the chain rule. But now, we're going to use this example. Yes, we can write it in terms of y, but we are going to use it to explain more about implicit differentiation. In our preceding videos, we are going to solve by implicit differentiation those functions that cannot be really written in terms of y. So how do we find the first derivative using implicit differentiation? Well, the first thing you do is to make sure you write this function in terms of dy over dx. And we know the dy over dx is y prime, and y prime is the first derivative. So for us to do that, we begin by, first of all, multiplying both sides by d over dx. D over dx of this function is going to be equal to, so we have x squared plus d plus y squared is equals to d over dx on the right side. And you notice we have not changed anything, because if you divide both sides by d over dx, then you go back here. Well, we are going to solve each term here in terms of, we are going to solve each term here with respect to dx. So if you solve, we find the derivative of x squared with respect to dx, then you're going to have x squared, sorry, if you find the derivative of x squared with respect to x, then you're going to have 2x, and we multiply that by dx over dx over dx. And one thing you notice, dx over dx is a 1. And then we add that to, again we find the derivative of y squared. We are going to find it with respect to x, and this is what will happen. Then we are going to have 2y, and we multiply by y, multiply by d is dy over dx, because we have a dx here, is equals to, if you find the derivative of a constant, then you have 0. So you notice that we have a term here with dx over dx, which cancels out to be 1. And then we have another term here with 2y dy dx. Then we can rewrite the function as follows: dx or 2x plus 2y multiplied by dy over dx is equal to 0. Our next assignment is to make sure we make this the subject of the formula, because the moment we make it the subject of the formula, dy over dx will become what we call the first derivative of our function. So for us to do that, let us take 2x to the other side. Then you're going to have 2y dy over dx is equals to negative 2. And if I can use the room over here, then dy over dx, dy over dx is going to be equal to, this is a negative 2x, negative 2x divided by 2y, and if we simplify further, then dy over dx is equals to x, negative x over y. And that becomes our derivative for our function right here. Well, how have we done it? So the first thing we do, we multiply both sides by d over dx, d over dx, and then the next thing you want to do is to differentiate each term with respect to x. So at the end of the day, you're going to have a term, at least a term or two or three that has dy over dx. If you have so many terms, then you're going to make sure you factor out the dy over dx and take those other terms to the opposite side so that you can write the function in terms of dy over dx. Because you know, if you write anything in terms of dy over dx, that becomes the first derivative. So that is exactly what we have done, and the derivative of our function is negative x over y, and that's how we apply implicit differentiation.